Lesson 3-2, solving equations with multiplication and divisions. And in this lesson, you learn to solve equations by using multiplication and division. Let's take a look at this real-world example. In 1990, Congress passed into law the Americans with Disabilities Act. One of the provisions of the law has to do with ramps installed on buildings to give people with disabilities access to those buildings. The law states that for a rise of 1 inch, there should be at least 12 inches of run. The maximum rise is 30 inches. Okay, so something like this. So you have your run right over here, and that's your rise. We'll talk about this later when we discuss slopes. Okay, so basically what it's saying is that to be able for disabled people to be able to go up on elevations, it has to have for every rise of 1 inch, there should be a run of 12 inches. So every 1 inch rise, there should be a run of 12 inches, and the maximum rise is 30 inches. Okay, so that it's going to be easier for a wheelchair to go up that ramp. Okay, so if a contractor wants to build a ramp that has a 180-inch run, what is the greatest rise that the ramp can have? Okay, so the table at the right, the pattern suggests that the run is 12 times the rise. Okay, so if we look at that table at the right, the pattern suggests that the run is 12 times the rise. Let x represent the number of inches in the rise, then 12x represents the number of inches in the run. Okay, write an equation to represent this situation. So for every 1 inch, there is a 12-inch run. So for 2 inches of rise, you have 24 inches of run, okay, and so on and so forth. And if you follow the pattern, you're simply multiplying this by 12, by 12, by 12. And therefore, if your rise is x, logically, your run would be 12x, okay? And since run is dependent on the rise, okay, rise is the independent quantity and run is the dependent quantity. Only positive values for rise and run. Makes sense. Okay, so we have the equation 12x equals 180. This equation will be solved in example 3. To solve equations with multiplication and division, you need new tools. Equations on the form of ax over b, where a and or b are functions, are generally solved by using the multiplication property of equality. Okay, so before we proceed solving that, let's see what the multiplication property of equality states. It simply states that for any numbers a, b, and c, if a is equal to b, then a times c is equal to b times c. So, or ac is equal to bc. Okay, so in the last lesson we talked about addition and subtraction properties of equality, and whatever you add or subtract to one side, you need to add or subtract to the other side. In this lesson we're going to talk about two properties, the multiplication and division properties of equality, for basically saying in the multiplication property of equality that if you multiply one side with a number, you need to multiply one side with another number as well. Okay, commandment number 8. In our math commandments, whatever you do to one side of the equation, you need to do to the other side as well. Okay, so that is a multiplication property of equality. Let's take a look at example number 1 and see how that property works. We're asked to solve g over 24 equals 5 over 12. Okay, just like what I've been telling you every single time, the first thing you need to do is copy the problem down. G over 24 equals 5 over 12. And again, if you recall, in order to solve for the variable g, we need to isolate g to one side of the equation. That means we need to undo 24. And using the multiplication property of equality, we simply multiply 24 to both sides of our equation. Okay, and this basically gets rid of our 24, because 24 over 24 is 1. So that's g over 1, or simply g. Okay, and if we simplify this, that is a 2. and that is a 1. So what happens is that now you have G equals 10. Okay, the value of G is 10. Again, to solve to check if our answer makes sense or not, we simply get the original equation and substitute the value of G, which is 10. 10 over 24, is it equal to 5 over 12? And yes, it is. And that means our our solution of 10 checks out. Let's take a look at example number 2. Okay, and example number 2, we're asked to solve the equation 3 and 1/4 p equals 2 and 1/2. Okay, again, copy the problem first. 3 and 1/4 p equals 2 and 1/2. Okay, if you recall, when you are multiplying and dividing with mixed numbers, you need to convert your mixed number into an improper fraction. So 3 and 1/4 is converted to 13 over 4 as an improper fraction. 13 over 4p equals 5 over 2. Okay, now again, we want to isolate p. Our objective is to undo 13 over 4, or find the reciprocal of 13 over 4 so that it will be equal to 1. Again, recalling that when you are talking about reciprocals, definition of a reciprocal is when you multiply a number with another number, the product would be 1. So you want to find a number whose product will be 1 when multiplied by 13 over 4. And in this case, that number is 4 over 13. So you multiply both sides with 4 over 13. Okay, and because the reciprocal of 13 over 4 is 4 over 13, okay, this equals to 1, and you're left with p, okay, equals 20, or actually, if you cross cancel, that was 20 over 26, or 10 over 13. You can do this. That's a 2, and that's a 1. Okay, end up with 10 over 13. Okay, so to be able to check this, okay, you simply have to go through the whole check process, and we'll find out that the solution is 10 over 13. Okay, let's take a look at 2b, example 2b. You have 40 equals negative 5d. Again, copy the problem. 40 equals negative 5d. Okay, d is on the right side of our equation. That means we need to isolate d on this side of the equation, which means we need to undo negative 5. And negative 5d is a multiplication operation, and in order to undo multiplication, we need to divide. So we need to divide both sides by negative 5, or when you divide both sides by negative 5, it is the same as multiplying both sides by negative 1/5. So basically what we want to do is simply divide both sides by negative 5 and negative 5. But when we divide both sides by negative 5, in essence, this is the same as multiplying both sides by negative 1/5. And that's exactly what we did. Multiplying both sides by negative 1/5, but negative 1/5. Okay, negative 1/5 times negative 5. Okay, both are reciprocals. You'll end up with a product of 1. End up with d equals negative 8. Okay, again, to check this, all you need to do is substitute negative 8 to the original problem, and we'll find out that this negative 8 will be the solution to this equation. Okay, and that is the multiplication property of equality. Actually, in letter B, I gave you a preview of the division property of equality. Let's take a look at the next concept in this lesson. Before we do that, let's look at this. Global connections. From 1985 to 1987, Rick Hansen, a wheelchair athlete, went around the world in a wheelchair. He covered 34 countries and 4 continents, logging 24,000 miles and raising money for wheelchair sports and research on spinal cord injuries. The reason why this is important is because the very first picture that I showed you was Rick Hansen, a wheelchair athlete, and that's the reason why his picture is there, because he made a major contribution in raising awareness for wheelchair sports. Okay, that's a sidetrack. Let's move on to the next one. The equation example 2b, which I told you I gave you a preview of the next property, was solved by multiplying each side by negative 1/5. The same result could have been obtained by dividing each side by negative 5, just like what I showed you. This method uses the division property of equality. It is often easier to use the multiplication property of equality. Okay, and this is what the division property of equality is all about. That for any numbers a, b, and c, with c not equal to 0. Again, why is there a restriction? Okay, because if c is 0, these numbers would be undefined. And according to our first commandment in math, thou shalt not divide by 0. So going back here, if a is equal to b, then a over c is equal to b over c. Simply put, if you divide one side of the equation with a number, you need to divide the other side with the same number. Whatever you do to one side of the equation, you need to do to the other. Okay, let's take a look at example 3, and going back to the original example, refer to the application at the beginning of the lesson. We want to solve 12x equals 180. Again, copy the problem. 12x equals 180. And in this problem, we want to isolate x on the left side of the equation, meaning we want to undo 12. And 12x is a multiplication operation, and multiplication is always undone by division. So we divide both sides by 12 in this case. 12 over 12 becomes 1. That becomes the coefficient of x, or simply x. And 180 over 12 is equal to 15. Okay, and checking our answer, okay, 12x equals 180, simply substitute the value of x, which is 15, see if they are equal, and true enough, it is. So the rise of the ramp could be at most 15 inches. So that is the rise of the ramp, which is at most 15 inches. Okay, that is example number 3, and let's take a look at the last example. Last example has to do with solving 3x equals negative 9. Again, copy the problem. 3x equals negative 9. We want to solve for x. Okay, and 3x is a multiplication problem. That means we need to undo 3, and in order for us to undo 3, we need to divide 3. Again, division being the inverse operation of multiplication. Dividing 3 to both sides, you end up with x over 3 equals negative 9 over 3. And this cancels out because that's a 1. Or we're left with the variable x. And negative 9 over 3 is negative 3. Okay? And if you want to use counters for this, let's take a look at this one. Recall that an equation mat is a model of an equation. You can group each cup on the left side of the mat with the same number of counters on the right side of the mat. Okay, so a mat is like an equation. So you have this. Why is it 3x? 3 cups, because the cups represent your x. Okay, remember variables are also placeholders. So the cups represent a value, and there's 3 of them, and you have negative 9 here. Okay, and if we divide both sides by 3, okay, something like this, you'll find out that each cup is equal to negative 3. See? So using counters, you can also conclude that x equals negative 3. Okay? And that concludes our lesson for today. On Google Forms or My Big Campus, type a summary of what you've learned by responding to the objectives of the lesson. Type a question you may want to ask in class about this lesson. Thank you.